Alright guys, so we're going to start looking at our circle geometry unit. So I got a couple slides here that I'm going to go through with you. Instead of me drawing this out, it's a little bit easier if I have the Smartboard software. Makes life a little bit simpler. So it's going to just look a little different this week. So we'll start off with a few definitions. So first off, we've got chords. So chords are line segments that have both endpoints on the circumference of the circle. Okay, so this red line going across the circle, it starts and ends on the outside part of the circle, so that is a chord. Okay, the largest possible chord you could have would be a chord that would go through the center of the circle like this. Okay, and if it goes through the center of the circle, then obviously it would have a special name. We would call that the diameter of the circle. Okay, so a chord is really just a line segment because it's not, the line doesn't keep going forever, it's just a portion of the line where it starts and ends on the circumference of the circle. Okay. Now we've got something called inscribed angles. So inscribed angles is an angle that's formed by two chords that have a common endpoint. Okay, so if I was to look at these two chords here, you might see the notation we would use would be something like, we've got this point here, we would call it A, okay, and it's got its endpoint right on the circle here. They have a common endpoint over here at B. Okay, so this first line segment we have is AB, that's our first chord, and then our second chord is the one that goes from B to, oh, I won't call it C, we'll call it D. Okay, so I have two chords, one that goes from A to B, one that goes from D to B, and because they both meet at this point B, that is now an inscribed angle because it is made up of two chords that share this common endpoint. Okay, one thing we would do with that when we refer to that inscribed angle is we would call it, we'd say angle ABD. Okay, and so what that does is we use the angle symbol here to denote that we're looking at an angle, and then we've got the start and end points, and then where the angle is formed is that letter right in the middle. Okay, so when I'm talking about the angle at ABD, I'm looking at the angle formed right here at B. Okay, so if I wanted to figure out the measurement of that angle, so maybe I've got my protractor here. So if I was to put my protractor, so remember I'm going to make sure that the 90-degree line and the baseline meet at my point. So I'm going to slide it in here like that. Okay, I want to make sure that the angle, my chord, is running along my 0 line at the bottom, and then this one I'm just going to use the slider. So remember, we always count from 0, so I'm just going to pull this up and I'm going to keep going until we hit our other chord, and so here we are on the other chord right there. It matches up, and you might not be able to see it because it disappeared very quickly, but the measurement there says 50 degrees. Okay, so this inscribed angle has a measurement of 50 degrees. Okay. We also have something called central angles, and central angles are angles formed by two radii of a circle. Okay, so that really just means that both of these points start from the outside and they meet in the middle, because this here forms the radius of a circle, and this here is also a radius of the circle. Okay, and so these have made a central angle because they meet in the center. Okay, so same thing, I'm going to find the measurement of this angle, so we'll bring it up so that my intersection is right on the point. Make sure that my chord is running through 0 here. Looks like I might need to adjust it just a little bit. Okay, so I got my chord running through 0, and then we'll bring this measurement up starting from 0. So we go up, this one goes past 90, and it hits, it looks like 100. Okay, so this measurement of this angle is about 100 degrees. Okay, so that's a central angle and an inscribed angle. Okay. Now we also have something called an arc. So an arc is just a portion of the circumference. Okay, so with this angle here, if I said that we had, let's see, this is a nice color here. So let's say with this one I had my points, and we had A, and we had B, and then here we had C. Okay, C we always save for the center of the circle. Okay, so when I'm talking about the arc is the portion of the circle that goes from A to B. This portion of the circle is an arc. Okay, now there's two ways to go from A to B. This is the shortest path that I just drew the purple on. So that would be called the minor arc because it's the shorter of the two paths. But I also have a major arc, and the major arc is the longer journey from A to B. So if I went around this way, and pardon my drawing, but it's very difficult with a mouse, if I go all the way around this way, this would be called the major arc. Okay, it is the larger portion of the circumference. Okay, so when we have an arc, we have a minor arc, and we have a major arc. Okay, if I'm looking at this as my central angle is opening up this way. Okay, and so it's opening up onto my minor arc, or the purple arc that we had drawn. Okay, and one of the things that we say is that the central angle from A to C to B, opening up this way, is subtended by the minor arc A to B. You'll see that word in just a minute again. So that word subtended really just means the angle is opening up towards that direction. So if I say it's subtended by the minor arc from A to B, it means it's opening up to this shorter arc. It is possible to say that it's opening up to the major arc, and I would say it's subtended by the major arc. And if I do that, it means I'm looking at this big angle here, and then it is subtended by this large arc here, the major arc. Okay? All right. So here we go. I'm going to start doing some of the geometry stuff now that we've talked about the definition. So here we go. I've got a nice inscribed angle here. I've got all three endpoints on the outside of the circle. And I'm going to measure this orange angle. So I'm going to just get my protractor in here. Let's see what the measurement is. This one actually looks quite nice. Let's see, I think this is starting from 0, we go up to where it meets the line, so that's a 30-degree angle. Sorry, there we go, 30 degrees. You can see it in the middle there. As soon as I click, it tells me how much my protractor is twisted. So we've got a 30-degree angle here. Okay, so I'm just going to make a quick note of that for myself. So I know I've got here, we've got a 30-degree angle. Okay, so this is 30 degrees. All right. Now, when I look at this, inscribed angle here, that angle is opening up to this portion of the circle, so it's subtended by this minor arc. Okay, and so what I'm going to do now is I'm going to draw another line. Okay, oh, I got to go here. I'm going to draw another line. I'll make it a different color so it's easy to see. Why don't we make it? We'll make it green. Okay, so I'm going to draw another angle, and I'm going to start and end at the same points. So we'll go from here, let's draw it over to this section right here, and then we'll go from there back up to here. Okay, so I have the same start and end points for this green angle, right? And if I look at this green angle, it's also opening up to the same arc on the circle, right? This green angle is opening up to the same arc up here. Okay, so it's opening up to the same arc as the other inscribed angle, and it shares the same start and end points as that inscribed angle. And what I'm going to do is I'm going to go and measure now. And if we were in class, I would be having you guys do this on your own. I would give everybody their own circles, and we would be doing this ourselves. But look at this. When I bring it up so that my chord is along my 0 line, and my other chord, look here. Here's my angle measurement. Look at what it is. It's 30. Those two inscribed angles are exactly the same. Both of them are 30. They had the same start and end points. They both opened up to the same portion of the circle, and they're both 30 degrees. So that's our first rule that we get with circles. Okay, so we get inscribed angles that are subtended by the same arc. So remember, when I say subtended by the same arc, it means it's opening onto the same portion of the circumference. Okay, they're going to be equal angles. Okay, so this angle from A down to B down to D is the exact same measurement as the angle from A down to E and back up to D, because they open onto the same arc, they have the same start and end points, so the angle measurements are exactly the same. Okay, so you notice here, start and end with A and D, start and end with A and D. The angle in the middle ends up being equal. Okay, so if two angles are inscribed and subtended by the same arc, they are equal to one another. Okay, so that means they're opening onto the same section of the circle. Okay, let's look at this inscribed angle here again. I have the exact same one that we had before. So this one, remember, measured 30 degrees. Okay, and what I'm going to do with this one is I'm going to keep those same start and end points. Okay, but this time, instead of going onto the outside of the circle, I'm going to go to the center of the circle. So let's pick blue. So I'm going to go from the outside of the circle here to the center of the circle here. And let's see what happens this time. Okay, so we know that orange angle, our inscribed angle, was 30 degrees. Okay, and now, oh, I missed it just a little bit. Okay, and now I've got a central angle, which again starts and ends at the same point as my orange angle. Okay, so my blue one is a central angle. So we said before, and I'll just kind of hover the protractor over there, you can see that one's 30 degrees, same as the one we had last time. So now I'm going to measure this central angle here. Let's see what happens. I'm going to tilt it this way. And, okay, so it's going through. It's, looks like I'm off just a little bit here. I gotta get it lined up. Oh my. Right click. Get out of here. Okay. I just gotta make sure I've got it lined up. There we go. Excellent. Okay. And let's bring our measurement up here. And it looks like I've hit at 60 degrees. Okay. Now I know it's it looks like it's 61. That's because I did a bad job with this chord right here. I meant to have it, let's see if I can fix it. There we go. I didn't actually have it lined up with that orange dot. Once I get it lined up with the orange dot, then I can zero it out, and now my angle looks much more like 60. Okay, so here we go, we get 60 degrees. Okay, and so what you notice is if the blue central angle is 60, and the orange inscribed angle is 30. Hopefully you can do some quick maths in your head. It's twice as big. Okay, so that takes us to our next circle rule. So when we have a central angle and an inscribed angle that are subtended by the same arc, so that means when my inscribed angle and my central angle both open up onto the same part of the circle, okay, so the angles that I'm looking at here, my central angle is always going to be 2 times bigger than my inscribed angle. Okay, so I have that written down here. So my central angle, A, D, and then the middle part is C. Same start and end points on the inscribed angle, but now instead of going to the center, I'm going to the outside. So if I take that inscribed angle and I times it by 2, I will get my central angle. So if this is 30, then my central angle would have to be 60. Okay, and it works the other way. If I know the central angle is 60 and I divide by 2, I'm going to get my inscribed angle. So you can use that one going back and forth. Okay, so it's important to remember the central angle is always 2 times bigger than the inscribed angle. Okay, now it doesn't just work with 30 and 60. Okay, those are the measurements that I actually took. But let's say I said this was 57. Okay, and even though it doesn't look like it, if the inscribed was 57, then the central would have to be 114. Okay, it would have to be twice as big. Okay, all right. So there's one last thing I'm going to show you. What happens if I take this diameter here? So with this diameter, you might remember from way back long ago, if you had a straight line has a measurement of 100 180 degrees. Okay, and so I've got my start and end points. We'll call that A. We'll call that one B, and we'll say the center is C. Okay, so my central angle right now is A to C to B. A to C to B. Right? It's formed by two radii, a radius from A to C and a radius from C to B. Just so happens that because they form one straight line, it's also called the diameter. So I still have a central angle here, ACB, that is 180 degrees in measure. Okay, so I'm going to take a line, and I want to have the same start and end points as my diameter. But instead of drawing a central angle, I'm going to draw an inscribed angle. So I'm going to go from A, and let's draw down to, I don't know, let's say here. And then we'll go from that point again back up to B. Okay, so now I have a new angle here. I have an inscribed angle, and that inscribed angle is going from A to D to B. Well, if A to C to B was central, and A to D to B is inscribed, from the rule we just looked at, this angle should be half as big. It should be 180, which is the central, and it should be cut in half. And when we divide by 2, we get 90 degrees. And this is actually the most important point of these circle rules here, is I get a nice 90-degree angle. Okay? So this is the last part. Any angle that's inscribed off of the diameter is going to measure 90 degrees. Okay, so all these angles that I drew in here, so if I go from A to B to D, well, A to C to D is the diameter, so that means A to B to D is a 90-degree angle. If I go from A to E to D, again, 90 degrees. If we go from A to F to D, again, 90 degrees. All of those measurements are 90 degrees because from A to C to D is a diameter, so it's a straight line which measures 180. So any angle inscribed off of that 180 is going to be half as big, so 90 degrees. Okay? All right, that's your basic introduction to circle properties. I've got a couple things for you to practice measuring some angles. The things I give you to measure your angles, I do not want you to use a protractor. I want you to use only these 3 rules that I showed you. So you know that inscribed angles subtended by the same arc are equal. You know that inscribed angles and central angles subtended by the same arc, the central must be twice as big. And you know that if you have an inscribed angle off of the diameter, the inscribed angle will measure 90 degrees. Okay, so those are the only 3 things you're going to need to actually figure out all the different measurements. So no protractors allowed. All right, good luck this week.